and that is a correlation coefficient. Okay, so I showed you when we ran our regression that it gives you the correlation coefficient. And the correlation coefficient is some value between -1 and 1. Right? The closer it is to the value of 1 or -1, the tighter the channel. So something like this. These are going to be pretty close to 1. Notice it's a really tight channel of points. It's not a very wide point. Right? This is the same thing, but it goes in the negative direction. Now, it doesn't matter how it's set. Right? If it has any kind of slope to it, positive or negative, and it's a tight channel, you're going to have a correlation coefficient that's either 1 or -1. The wider your channels get, so notice this one's wider, this one's even wider, and this one's extremely wide. There's really no channel at all. Right? Now your correlation coefficient's getting to be closer to 0, right? Up until the point where there is no specific line that fits that pattern. Okay, so this is all how close to a straight line the data points are representing. Okay. And then all of these, even if they're somewhat tight in a channel, if they don't form a straight line, then they have 0 correlation. Okay. So as far as positives and negatives, if the slope of the line is positive, then the correlation coefficient is positive. If the slope of the line is negative, then the correlation coefficient is a negative number. Okay? So again, how narrow the channel of points is how close to the number 1 or -1 you get, and then positive and negative indicate whether it's increasing or decreasing and going up or going down. All right. So when you are finding these correlation coefficients, you're simply going to do the same thing that we just did, but you're going to look in the table that pops up with the information. You're going to identify the one that says CORR. Okay? So what I want you to do is I want you to see if you can find the line of best fit for this. And find the correlation coefficient. But remember, so you're going to be using your TI-89s. You're going to open up the data matrix editor if it's not already open. Okay? You're going to enter this information. And then you're going to go through the steps to identify and calculate the line of best fit. So from your home screen, if you hit this Apps button, this purple button right here, Apps, you can scroll down to where it says Data Matrix Editor. Choose Current. Right? You should now have one in Current. Now you can type directly over old cells. So if you know you're going to be using more cells than what you have, you can just type over it. Or if you hit this F1 tab, you can clear the whole thing by hitting 8, confirming it, and then just starting new. Okay, what I would do on the TI-89, I would work through whole columns because the Enter button just advances you down the next column. So I would just enter all my X's first. And then I'd go back up to the top and enter all my corresponding Y's. All right, once you enter all your data, you then go to your Calculate tab, F5. You need to change the calculation type to linear regression, which is option 5. We need to identify what cells contain our X's and what cells contain our Y's. So C1, remember it's already alpha locked, so I'm going to hit the button with the C. Then I have to deselect alpha key to get C1. use the down arrow, get to the next field, alpha to access C2 for my y. And again, I'm going to store this regression equation into my y editor. So I'm going to choose here to the right. It can be any one. Again, I'm just going to go ahead and use y1. And when I do that, I hit enter. So my option right now is I can either write out my equation based on this. Okay. So here I have 1.99x. So my equation is going to be y equals 1.99x. And then my b value, my y-intercept, is 8.38 if I round to 2 decimal places. So plus 8 point, or actually it rounds to 3. So 8.378. So there's my line of best fit. Okay, and then the correlation coefficient is located right here, 0.981791. Again, to 3 decimal places, it's 0.982. All right, now what this number means is my slope is positive, which I see from my line of best fit anyway. And the fact that it's 0.982 is relatively close to 1, it means that it's somewhat narrow channel, okay, and it's going up or increasing. Okay, so that's the information that the correlation coefficient tells me. So it's a relatively good line of best fit. And so you're going to get somewhat accurate predictions from this. Again, it is still just a prediction. Okay, and so if I wanted you to find your output when x is equal to 20. Would this be a case of interpolation or extrapolation? 20 falls outside, so that is extrapolation. Okay, and so the way I can do that is I can go to my home screen. Since I stored this in my y1 editor, I can simply take y1 of, do my evaluation. My function notation, y1 of 20, is going to plug 20 in for my x to this equation, and I get my answer, 48.18. And what if I ask you, find y when x is 7/2? So 7/2 is 3.5, so that falls in between or within the values that were tested. So this is an example of interpolating the data. Right, and so if I wanted to find what that would be, I could simply reevaluate 7/2, and I get 15.34. Now, when I look up here, does that seem like a reasonable answer? Again, it's not going to be exact. It is a prediction, but here between 3 and 4 is 15 point something. Again, it seems like a reasonable answer.